Let's go through equals 3,196 maximum total cost of alternating subarrays. For this question, it gives us integer array nums. And in the array, they may have positive and negative numbers. And we can separate this kind of nums as many as we can, right? And for each part, we apply a cost function. This cost function is doing the alternating plus or minus those kind of elements and sum it up. And it asks, for example, we subdivide into different cost function, cost result of different subarrays. It asks what's the maximum total sum of those cost results. I say that we can divide the split this kind of array as many as we can, right? And of course, we can get this a bit difficult, increase the difficulty. For example, limit how many subarrays. For example, we can have a limitation case here, get more complicated. But since as long as for this one, we can separate as many as we can, right? The things that one of the conclusion is that if we already have this kind of subarray to, for example, nums I and so on, right? For the new incoming nums I, we have options to separate, have a divider here, right? And or do not divide or just append. So the things that one of the conclusion is that we want to draw is that to append this to the previous array, it is equivalent to have a separator here or have a separator before n minus 1, right? We want to say append is just a special case to one of the cases to have separate here or separate here, so that we don't need to worry about append case, right? We just need to care about have a separator. When there is a new nums coming, we have separator before this nums. Use a new subarray for this nums, or we include one of the previous nums to nums I. So let's consider whether this is equivalent, right? So if from this kind of index to nums I minus 1, if this is a positive index, right? So we are going to add nums I minus 1 and minus nums I minus I, right? So we'll see if we have separate here, right? So that is also total result add nums I minus 1 and minus nums I, right? So we'll say append this is equivalent to have a separator on nums I minus 1, right? And if this is an even number, right? That means if we append here, we are going to add nums I, right? So that is also equivalent. We have a separate before nums I, right? So in this case, we'll say we can ignore those kind of append nums I to previous section, right? And we just need to consider we have a separator before nums I or before nums I minus 1, right? So if we know this kind of conclusion, we will get our solution easier. So for every nums coming, we have two options, right? So one is that we have separate before nums I, and another is we have separate before nums I minus 1, right? So when should we choose the before nums I and the before nums I minus 1, right? So what we're thinking about is that if this nums I is a positive number, for example, positive 10, right? So the optimal solution for us to add total cost to be increased to increase the total cost is that we have a cost, a separator before nums I, right? So that we are always add this number, so it will always increasing. And if this is a negative number, for example, -10, right? This we're going to have two cases. One is that we have separate here, and another is separate here, right? So we are going to get the maximal of these two. And so this is, for example, we already have the total cost to maximal cost to I-1, right? Then we are going to have these two options as to transfer from dpi-1 to dpi. If this is a negative number, that is, we have options to have separate before nums I, or have options to have separated before n-2, n-1, right? And get its maximal, so that we know we calculate to nums I what's the maximal total cost. And in the end, we just need to find the dp n, right? So let's write code for this. We know we just have a dp function, right? Int n equals nums dot length, and we'll say long dp equals new long. We can have one more index, right? So that we'll have a dp0 always to be 0, right? So dpi we're going to means at nums I-1, right? The max cost sum. So what we do is that we're going to have dp 1, right, equals, well, always to be 1L multiplied by nums 0. Then what we do is that for int I equals 2, I smaller than n plus 1, I plus plus. So I say if nums I -1, if it is a positive number, right? So we'll have a separator before this nums I -1, right? So we'll say dp I will be dp I -1 plus nums I -1, right? And else, if it is a negative number, right? If it is negative, what we do is that we need to have two choices. Find out whether we have separated before this nums I-1 or before nums n-2, right? So we have max dp I plus 1. So this is a negative, right? So we'll add a nums we have separate here, I-1, or we are going to have a dp I-2, and we have this kind of separator at nums I-2, then we need minus nums I-1, right? And in the end, we just return dp n. So this will be the solution. And doing like this, the time complexity will be O(n), and space will be O(n) as well, right? But we'll find every dpi is actually only depend on I-1 and I-2, right? So actually, we don't need for the space, right? We don't need to have a log array open, right? So we can use the 3 variables to do this. So to have 3 variables, we can change, right? We use the D2 means I-2 and D1 to be dp I-1, right? And also use that dpi. Okay, so what we do is that we are going to have long D2. At the beginning, we'll say this is 0, right? And D1 equals always will be nums I 0, right? D1. And we are going to have a D, right? So let's set D. Let's set D as D1, right? The reason we set this D as D1 is that if this length is just 1, right, we just return D. Otherwise, we'll have a special corner case that when nums I equals to 1, we are going to return D1, right? So if we set D as D1, right, because we are going to update the D when index greater than 2, right? So what we do is for int I equals 2, I smaller than n plus 1, I increase I, right? So if D equals, if this nums I minus 1 is greater equal to 0, right? If it is greater equal to 0, what we do is that we are always have D1 plus, sorry, I minus 1, right? Plus nums I minus 1, right? So when this is greater, and if this is smaller than 0, then we're going to have the max max D2. And we are going to have a separator before nums I minus 1, right? Or we have a separator before nums I minus 2. So that is plus nums I minus 2 minus nums I minus 1, right? And here, after this, we're going to have D2 equals D1 and D1 equals D, right? So this order matters. We should not mess up these two orders because we need this value not change, right? In the end, we just return D. Okay, doing like this, the time complexity will also be ON, and the space complexity will be constant, right? And we have Python solution as well. Let's have n equals length nums, okay, and we have d2 d1 d equals 0 nums 0 and nums 0, right? So what we do is that for I in range from 2 to n plus 1, right? What we do is that so we'll say if nums I minus 1 greater equal to 0, right? Then we'll have d equals d1 plus nums I minus 1. Then we'll say else d equals max d1 plus nums I minus 1 or d2 plus nums I minus 2 minus nums I minus 1, right? And after this, we'll reset the kind of D1 and D2 values, right? D2 equals D1, and can have D2 equals D1, and D1 equals D, D1 equals D. And in the end, we just return D.